Hello and welcome to this edition of Trumpf's Ask the Expert. My name is Philipp Rettenmeier and I'm working for the product group Laser here at Trumpf in Farmington. I'm a sales engineer and as you may hear, I'm a German, so I apologize for my dialect. So in this episode we're going to talk about laser welding because a lot of our customers are pretty interested in that topic at the moment. And what we're really going to talk about is parts and requirements of parts to laser welding, which means I will show you some examples of parts which can be perfectly laser welded. So let's have a closer look at the production, for example, at your company. We're going to talk about production of sheet metal parts. And at the very beginning of these sheet metal parts, you always have to design these parts, which you would probably do with CAD or CAM software. After designing these parts, what would you do then? You would probably cut or punch these parts out of flat sheet you would probably use either typical punching machines or laser cutting machines, which means with these machines you have definitely perfectly cut parts afterwards. After this, what would you do then is you would do bending. And you would probably invest a lot of time in optimizing these bending processes because the parts have to be bended perfectly, what you probably do. And after these processes, what would you do then is you would join them, for example, with conventional welding processes like MIG, TIG, and MUG welding. But why would you do that? Before that, you did perfect quality, and afterwards you put that large amount of heat in your components, which means if you want to have nice weld seams, you have to grind them. And these grinding processes with this grinder take a lot of time, and that is why we want to start to talk about laser welding, because there you can probably get rid of most of these grinding processes. So we had a closer look in our department on the production time of typical sheet metal parts which are welded afterwards. So first of all, let's assume that these parts are welded with conventional welding methods like MIG, TIG or MUG welding. And they definitely have to be grinded afterwards. So assume that the production time of these parts is 100%. But now let's have a look what the time reduction was when you replaced these old processes with laser welding. So you could definitely benefit from a time reduction of 86% on average, which we determined for these parts. And this not only makes your production more flexible, and you could definitely reduce or eliminate the bottleneck of your production, which is typically the welding and the grinding processes. So let's start talking about the points which clearly speak for laser welding. In order to make the production of your company smarter and faster, we from Trumpf will definitely help you by getting rid of these processes like the grinding process, and we could do that with laser welding. So let me demonstrate this on an example. What you can see here is an electrical housing produced of mild steel. Sheet thickness is 60 thousandths of an inch, and on the left you can see the conventional welded part, which was MIG welding process, and on the right you can see the laser welded part. So with conventional welding, which was MIG in this example, which you can see on the left, the production time in total was 5 minutes including grinding. And we had to grind this part because this is a part of a machine tool which is visible from the outside. And you can see here the grinded corners of the conventional welded part. Compared to that, you can see the laser welded part on the right, and you can see the weld seam quality here. Directly from our system, which means the weld seam is nearly invisible. For the laser welded parts, the production time took less than a minute, which was a time saving of more than 80%. Next point is complex weld geometries like curved shapes or thin sheet thickness, or even material combinations regarding thickness. These pictures show examples of a mild steel cover and a segment of a stainless steel counter, both with curved weld seams. Imagine how difficult this was with TIG welding. For laser welding technology, no problem at all. This is a very important aspect at the moment, since end users tend to invest more money for highly designed parts. Another big topic at the moment are, for example, water or pressure tanks. We currently have a couple of customers who are highly interested in laser welding of these parts, since the conventional welding processes are used close to their feasibility. Therefore, laser welding offers perfectly sealed and tight weld seams without any refinishing at all. Thus, production of tanks can be greatly converted to laser welding. An enormous advantage of laser welding is definitely that the weld quality of the weld seams is consistent. So compare this, for example, to the welding processes in your facility. A laser welding cell always produces consistent results of perfect weld quality. So let me demonstrate this on one of our sample parts, which is shown here. It is a weld corner made of stainless steel and produced with so-called heat conduction welding. And with heat conduction welding, which is part of laser welding, you can produce really cosmetic weld seams like these corner weld seams over here. And this weld corner here was produced without any refinishing at all, which means it's direct from our laser welding cell. Besides, don't forget that the amount of heat put into a sheet metal part is way lower for laser welding compared to, for example, MIG or TIG welding. Thus, we can dramatically reduce distortion or twisting of a part with laser welding. What about your MIG and TIG welded parts and the distortion caused with these welding processes? Last, I want to focus on possible joint geometries. For arc welding processes, this is basically restricted to either butt or fillet welds. With laser welding, we have the possibility to use multiple joint geometries. Let's have a closer look on these two parts over here. The right one is made of stainless steel and the left one is made of aluminum. Not only that we can produce stiff weld seams by use of deep penetration welding, where we can produce a fully penetrated weld, but also we can produce, as shown before, nice corner welds by use of heat conduction welding. And additionally, we can also produce overlap joints like this joint over here, which gives us the full flexibility of this laser welding technique. Thank you for watching this episode of Ask the Expert. If you have any questions, you can definitely contact the product group Laser of Trump in Farmington, Connecticut.